All right, hey, it's February 22nd here, Monday morning at 6. We're looking at the 6Z chart here, 500 millibar pattern for the hemisphere. And I don't know if you remember the Hove-Moller diagrams from last time. The Hove-Moller diagrams kind of show us the wave activity around the hemisphere. And that showed me that we had a couple of waves here. One was at 0 longitude. There was another one at 150, another one at 130 east, and another one at 85. So those are kind of like where the long waves are parked. And remember, in between all of the troughs are ridges. So we're going to find a trough or a ridge here, long wave ridge there, another one here, and probably another one right there. These are not moving very much at all, and that's typical with a 3 to 4 wave pattern, like you see here. But superimposed on that are short waves moving through the flow. So there's one right there, and in between each trough we have a shortwave ridge. So you see what I'm doing right there? There's a ridge right there, and there's a little ridge moving there through the Pacific, and another trough. So that's kind of the pattern we have stacked up, and what we're going to be watching is this major shortwave trough moving in the Pacific Northwest. And you can see that's moving into the long wave ridge. So that's going to weaken the trough temporarily until it gets on the backside. So here you can see we've already got kind of a key to what's going on. Meteosat, or the GFS chart here, this is the model from 0Z. There's that ridge, that trough we're interested in right there off the west coast. So we run the charts forward, and you can see that shortwave moves to the other side of the long wave ridge. And by 48 to 72 hours, it's already down in Texas. It moved kind of like that. And there's another piece of it up north. That probably rode around the north side of the ridge. So we're interested in this area. One site that I think is pretty cool to look at is the SREF, the Short Range Ensemble Forecast. This is a subset of the NAM model. And SPC has got this good experimental product. If you go to spc.noaa.gov/exper, there should be a menu that will take you to this page. So we'll park this on, well, yeah, we'll park it for 12Z because that's what it's about right now. So I'm looking up here at the top at 412Z. And this is the setup we have for this morning. So in between the high cyclonic vorticity and the high anticyclonic vorticity, that's where we find our jet maxes. So the biggest one we have right here is in California. This is along this area of vorticity gradient, the dashed blue lines, where they're very tightly packed together. So this is a polar front jet starting to dig down into the base of this long wave trough, and I'm going to show you the sea level pressure and thickness. That's going to be this product right here. And I'll advance this up to 12Z. So what do we have here? This is the surface and low level, mid-level configuration. What's important here is the thickness. That's a measure of the mean low and mid-level temperatures. You can see we've got this very strong gradient in the southwestern U.S. That's dividing very cold air in the Pacific Northwest and the northern Rockies from very warm air in Baja California and the Gulf of California. So in between that, on the warm side of the gradient, we're going to find a front. That's going to be about right like that. And then it links up into Texas, probably to that low right there in Louisiana, and then off the coast. So that's the polar front location, like that. Now you remember from the upper level charts, we've got that energy moving from the Pacific into California. You can see already that that's going to link up with the polar front boundary. So that's going to be what sets things off over the next 24 hours. And you can also tell that if you're very interested in this stuff and you want to look at the satellite pictures and the surface data, you want to focus on this area right here, Arizona. That's going to be for today, and then as the upper level energy links up and with a front over in Texas, this is what we're going to watch for Tuesday. So what do we have for that situation on Tuesday night? That's kind of where things start to get a little bit interesting. I'll run this up to 0Z on the 24th. This is Tuesday night. If I draw the jets, they're going to look something like this. There's high cyclonic vorticity right there. You can see that vorticity gradient is stronger right there, so that there's probably a jet max right there southeast of Houston off the coast. Now if you remember the 4-cell concept of upward and downward vertical motion, that tells us we're looking at upward motion right there in northern Louisiana and Arkansas. That's conducive to upper level, or I'm sorry, not upper level. It's conducive to lift, clouds, cyclogenesis, removal of air mass from this region, and surface convergence. So we're going to look for this area to be active. And in the backside, in the left rear quadrant, we're going to be looking for subsidence and improving weather. South of the jet in this curved flow, it's indeterminate, so we don't really know. So how does that match up with the surface data? Switch back over to thickness and run this up to 0Z. And look at that, there's the surface low right about where we expected it. And we can just paint in the rest. Cold front like that, warm front like that. And the main area we're going to be looking at for severe weather for Tuesday night is going to be in northern Mississippi, northern Alabama. See that backed easterly flow? Kind of like right in this area. Backed easterly flow. That probably intersects with an 850 millibar jet supplying a good bit of moisture northward. So things should be kind of interesting for Tuesday. Let's see, and then what happens later on? Well, by 12Z, most of that is moved through Alabama into Georgia, and now it's taking aim on the northeast U.S. So that's what we're going to be looking at later for the 24th, for Wednesday. Things getting interesting there around West Virginia and Pennsylvania. And then out behind that, we get a pretty good kick of cool air coming in behind the system. So do we see any trace of that pending system going on? Let me run that back and show you. See, 12Z is about right here. Remember, we're looking at California and off the coast. We're going to expect to find some cloud material maybe ahead of that, like in this area, eastern Nevada, Utah. So you can kind of use a satellite picture to verify that. Let's zoom in on that. I've already set the width like that. We'll click on it, and that's actually, I want to make that low zoom. So that's interesting. That kind of sort of matches up right there. See that area of cloud? This is a upper and mid-level cloud there in eastern Nevada. That's going to be ahead of that little piece of upper level jet stream energy. So you're going to keep an eye on this over the next 12 to 24 hours, and then watch for stuff to start developing down in this area. So that's what we're watching for the next day or so, and then, you know, looking at the satellite picture, you might think we're focused on this, but no, that's going to be a lot later. What we're interested in is this area right here. And the satellite photo I'm showing you, this is infrared data. This is 1230. It's dark right now. So we're seeing temperature. And it's mostly the upper level clouds that are showing, not so much any low cloud material. So you can see a little bit of low cloud in this area here of the Pacific. That's stratocumulus due to cold air advection moving out over the slightly warmer waters. But the very white colors, that's all higher level cirrostratus, altocumulus, and altostratus and stuff like that. So there we go. Things should be a little bit more interesting tomorrow, and we'll probably try to update that with some more, give you some more videos and let you see what's going on.